Wasabi, you guys. We have this weird looking trig sub integral, even though it's not exactly trig substitution. But whenever you see something like this, anything in a form like this, okay, this could actually be generalized. Like it actually can. Pretty much, so there's two ways. The force u sub and the inverse secant way. So usually, you can actually let, let's say, x squared, x here, and this becomes like a half of like, from 1 to infinity, you get du of u squared. Oh, would you look at that? This is equal to a half of inverse secant of u, which is x squared. Okay? And so now we have from 1 to infinity, this is what, plug infinity, you get pi over 2. This is a half. Pi over 2 minus inverse secant of 1 is 0, right? So I believe our answer is pi over 4. Okay. But how do we generalize that? Right? This is just in case if we do come across something like, what if this was like a 5, right? So here, you could actually use, if this is easier for you, you can do force substitution, or force u sub. So xn, and we have xn minus 1 dx. Right, so pretty much I multiply top and bottom by x to the power of n minus 1 to here, and we get this. And then if you let u equal square root of xn minus 1, u squared plus 1 is equal to xn, and then 2u du is equal to n x to the power of n minus 1 dx. So now you have 1 over n. This is going to be, what, 0, infinity, and then because I don't think I did this correctly. Oh, the 2u du. Ah, I knew something was wrong. I'm like, huh. Oh no, if something's not right, please double check. Okay? So, thankfully, I caught that. It's 2u. I don't know why this is a dx. It should be du. But 2u du. Don't forget that. Now, it makes sense. This is 2 over n. This is inverse tangent of u, which equals x square root of xn minus 1. Okay? So this is the generalized. If you simplify it with like trigonometry or whatever, it's the same thing as kind of like inverse secant of what, x to the power of n over 2? I think that's what this is. I'm not quite sure. Don't trust me on that. But you could write this answer in inverse secant form. But if this is easier for you, then this is the way to go. Oh, I don't know why there's plus c. I have bounds. This would have been what, 0 to infinity. You can't plug the. Oh, it's because I plugged in. Oh, well, if this was to actually evaluate this, 2 over n, this would have been pi over 2. Pi over n. Would you look at that? So this, like originally, like how I had it, the answer was indeed pi over 4. Okay? Alright. I'll see you guys in the next video.